Section 26.5, Earth's Moon. So the moon is something we know a lot about. It's the only thing in space that's not Earth that we've ever been to, right? So we know more about the moon than probably anything else. The moon is about a quarter of the size of Earth. It has no atmosphere, it has no weather, no erosion. Okay, so it wears all the scars of all its previous crater impacts. We also see things, for example, when the astronauts were there, you can still find the footprints from the astronauts, because with no atmosphere, that means no weather, that means no wind. Wind doesn't blow those footprints away, they'll stay there forever. So the moon rotates just like the Earth as it revolves around the Earth. And the way that that happens is actually really interesting, which we'll talk about in just a second. As the moon goes around the Earth, there are 2 points in its revolution where you can have different things occur. So if the moon moves in between the sun and the Earth, then you get a solar eclipse. And that just means that the sun's light is blocked by the moon and it casts a shadow on the Earth. A few years ago, I think it was 2017, there was an eclipse here where we could see it really well. There are eclipses all over every year or two, but they're all in different regions of the Earth. It really depends on how the moon, Earth, and sun line up. Though the solar system is essentially flat in terms of all the planets kind of revolve in a single plane, save for maybe Pluto and some of the stuff on the outside. The moon is similar to that with Earth in that it revolves in the same plane, but that plane is tilted just a little bit. And that little bit of a tilt means that the moon, Earth, and sun don't line up all the time, only on particular occasions and in particular places. If there was no tilt to the moon's orbit around the Earth, we would get a solar eclipse and a lunar eclipse every month as it moved in front of the sun. A solar eclipse is when the moon blocks the sun, casts a shadow on the Earth. And a lunar eclipse is when the Earth blocks the sun and that shadow is cast on the moon. Now, in terms of a lunar eclipse, what you see is you don't see the moon disappear like you do with the sun. You see the moon becomes very, very red over time, and then that redness will move away. Because of the positioning of the Earth, moon, and sun during a lunar eclipse, light from the sun can still make it around the Earth and through the atmosphere before it hits the moon. And so that light appears to be red because it's traveling through a lot of atmosphere. The same way sunsets appear to be very red because the light is traveling through more atmosphere. In terms of a solar eclipse, the reason that the moon is able to block out the sun is actually super interesting. It doesn't seem like it to you, but the moon and the sun, though very different sizes in general, in our sky, the moon and the sun are the same size. They appear to be the same size to us. It doesn't seem like that's true. But if you go outside and you take your hand, hold your hand, extend your arm out, and hold your thumb up, right? You're going to be looking across your thumb at the sun or the moon. And what you'll find is that about half your thumb will cover both the sun and the moon. If you do it that way, you'll notice then that they're about the same size in the sky. The other way you can notice they're about the same size in the sky is that's the only way a solar eclipse works. If they're not the same size, say the sun's bigger than the moon in the sky, then you could see the sunlight behind the moon, and it would just be a shadow they cast across the sun. If the moon was bigger, it would completely block out the sun. You wouldn't be able to see it at all behind it. But instead, what you see when you see a solar eclipse is the moon moving in front of the sun and blocking every bit but the halo corona area on the outside. So they are the same size in the sky, and that's why solar eclipses work. And because of the fact that the moon will move in front of the Earth every once in a while and not every month. The last thing to know about the moon, and to me this is one of the most important things because this is the thing that everybody messes up. The phases of the moon are due to its position relative to the Earth. The moon is illuminated in the same way at all times. You always have one side of the moon lit up and one side dark. Okay? But depending on where you are on Earth as this thing moves around, remember this revolution as the moon goes around takes about a month, about 28 days. Hence, the name of the word month comes from moon. So it takes about 28 days for this thing to go around. At the same time, the moon itself takes about 28 days to rotate on its axis. So it is rotating and revolving simultaneously. So what that means is that on Earth, we only ever see one side of the moon. And we only ever see this illuminated side. Now, if you could see the dark side in the sky, right, you could see the other part of the moon, but that part's not illuminated. The sun is over here somewhere, shining onto the moon, and it's always shining onto that same side. So when you have a new moon, which is where you have no moon in the sky, essentially, or it's darkened, that means the sun's on the backside, and you can't see it. When you have a full moon, then the sun's on the front side, and you can see the whole thing. At the quarters, right, you have 90-degree angles. The sun's over here, and the Earth's over there. Same thing here. The first and third quarter just have to do with its location on the way around. And then the phases in between just show the change as you go from new moon to first quarter, full to third quarter, and back. So what we call this is, it's called a tidal lock. And what that means is that the rotation and the revolution period are equal, or proportional ratios of each other. Mercury is tidal locked to the sun. But that's that 3-to-2 ratio we talked about. The moon and the earth are tidal locked, but it's 1-to-1. It rotates at the same time that it revolves, and that's why we only ever see that one face of the moon.